Okay, today we will go to the diode rectification. From next week, you take one. We will get a lecture in room 240 on Monday. Okay, I still try to make sure in room 240 I can work with my iPad, and also I try to see if I can record it, the lecture. Okay, if no problem, then we will be get the lecture on Monday at 3 o'clock. Okay, so you can say this is sideway. I believe you already know. Okay, what we need, that means everything in the display. Okay, you see sideway, and what is the V pitch to pitch? What is the V pitch or VINF? Okay, we already get through that. So we have to move it, okay? Now, they're talking about diode. That's what they call a PN junction. On the P type, they contain positive, the whole. And on the N type, they get an electron that's a negative. Okay? So they can be using either silicon diode or germanium diode. For silicon diode, the voltage VD 0.7 volt, germanium VD 0.3 volt. Normally they're using a silicon diode. Now, for the diode symbol, if you say that simple, then you have to know this is a diode. On the one side, A, that's for anode, and another side C for cathode. Okay, so basically the diode voltage VD equal VA minus VC. Okay, that means the voltage across the diode. Diode normally permit electron current flow only in one direction. That means the current can be flowing. Okay? They draw this way. I. Okay? The current I is flowing. Normally, you can see we draw different way. I. Now, what that means? When you see the current flow this way, that means in the textbook, normally they draw this way. That's just telling you electron moving. However, we're working with a conventional current, so current has to be flowing from positive to negative. Even that's the same current. Okay? One they draw current following electron moving. Again, we're using the current flowing from positive to negative. That's what conventional current. Okay? So when you see the symbol, okay, you have to understand this is a diode. One side anode, the other side cathode, and the voltage across the diode will be VAC. That means VD. And VD equals VA minus VC. Now, they just given you the diode, okay, ideal, okay. Normally the diode, when they open, they like the switch right here, open. That's only thing they know current flowing from anode to cathode, okay. When they go, when they working, that means they allow the current flowing from A to C. Okay? So if you're reading here, ideal diode, what that means? Ideal diode, that means VD equal 0 volt. Okay? Never happened. Okay? We cannot get the ideal diode. Okay? Only thing is, when they not get the current flowing, they open. Okay? When the current gets flowing, they close. That will be same thing in here. Second, approximation. This is the diode. When they open, that means VD. That will be A. That will be B. Okay? When they open, then you know VA. Sorry, I can that one. VC. VD. Okay? Equal sorry, less than. If VAC or VD, okay, less than 0.7, they open. Right here, they open, okay? And that will be telling you no current flowing from A to C, okay? And now, when they close, they're telling you VD greater than 0.7 volt. Okay, so that will be telling you one thing. You get a diode. When they open, do not dip the diode this way. You have to send to here. See here. Okay, that means they open. So, and when they close, here, see here, you must be substitute diode from the battery. Plus, minus 0.7 volt. That's the key point. Okay? So only thing when you're working with a diode, you have to come up with the open or the close. They open. Then you have to redraw that diode by open. And if you say the diode is closed, you substitute diode by the battery. Like I show you here. Okay? That's the key point to do diode. Now, example 1. Okay? You get a power supply, 10 volt, and this is a diode. Now, how do we know diode on or diode off? Who knows? Telling me.
The diode on?
On or off?
It's on.
How do we know it's on?
Because the current is going downwards.
Okay.
Because
Go ahead.
yes,
I'm telling you. When you see that circuitry here, you have to know what the out supposed to be. Right?
yes.
Okay. So, first thing you have to do, no diode here. That means you have to suppose if without no diode, what the out equal. If you don't have a diode in the circuitry, What the out equal? Just telling me whatever you think. That's what I try to help you out.
0.01 milliamps?
What?
0.0 amps?
No. What I telling you. If you don't have a diode here, no diode here, what we out?
First of all, Mr. Pham, you need to know the diode is on when the anode is more positive than the cathode. But to answer your question, V out equals it equals 10 volts because there's no current flow through um, R limit.
Okay.
It's 10 volts. That's your answer.
Okay, now I can tell you the current flowing this way, right?
Right.
When you say no diode, I equal 0, right? Open circuit.
Right. Exactly.
Open circuit, that means I cannot flowing. So no current flow through 1 kilo ohm. Then
Basically, you're measuring the voltage across the
then the
10 volt.
voltage this side
Right.
and voltage this side the same. Okay? So they supposed to be 10 and volt. The thing they know voltage drop across 1 kilo ohm. Make sure if you get any question, just bring it up. I can help you out. In order to solving the diode problem, that is the first thing you have to do. If we have a no diode there, what the V out equal? Okay? If no diode there, that means the circuitry open. Current flow equal 0. That's telling you no current drop across 1K. Okay, if they not drop any voltage across the resistor, that means the voltage have to be same thing. Okay, now that will be telling you. Okay, in order to know the diode on or off, now you know 10 volt. With the diode, they will be on. Okay, now they on. Then we can get the diode back. Okay, so diode will be on. Diode off. Now, next step. The first step, you have to come up with diode on or off. Okay, we already done. The second step, I already said, when the diode on or off, you have to substitute diode. Okay? You say diode on. You must be substitute the diode by the battery. And positive here, negative here. voltage equal 0.7 volt. Okay? Now, what we out equal now? Forget this guy, okay? Now to deal with the battery. 0.7 volt. With the positive and the negative, what we are equal?
Is it 0.7 milliamps?
All right, 0.7 volt. That's the voltage of the diode. So the answer will be 0. You get that? Make sure you have to understand that the bill for your basic minimum thing you must know. If any question, just let me know. So, again, when you say the diode on, do not see simple and on the diode anymore. You must be substitute the diode by the battery. For silicon diode, VD equal 0.7 volt. Okay? Now, current will be flowing. Here, current will be flowing out. How do we calculate the current I? I equal. You get the voltage one side will be 10 volt. The other side here, 0.7 volt. Ohm law, right? Remember Ohm law. V equal R times I. I equal V divide R. R equal V divide I. So you get the V. Okay, one side is 10 volt, the other side 0.7 volt. Resistor 1K. So I will be equal 10 volt minus 0.7 volt divide 1 KO. Okay, equal what? 9.3, right?
Right, 9.3 divided by 1K.
9.3 divided by kilo ohm. Then automatically you know you get 9.3 milliamp. Milliamp.
So are you saying it's 9.3 milliamps?
Yeah, the thing is you divide 1K in this formula. Okay, V, let's see, in volt, R in ohm. then you get ampere. However, not ohm, 1K. Is it 1,000 ohm? So that's why I get milli. Whenever you divide voltage to kilo, you have to get milliamp. Okay? Now, what the voltage across here? VR. VR, you know, on law. Okay?
Is it 0.1?
R times I. Right? On law. You already get R, you already get I. That's why you can calculate the VR1. Or sometimes you don't have to using this formula. You know this side 10 volt, this side 0.7 volt. So the voltage across R will be 9.3 volt. Okay. Any question about example number 1? Try to make it clear for you guys, okay? Any question, anything else? Okay? Just let me know. Example number 2. Now, if you're looking into the circuitry, I want to tell you, you must come up with diode on or diode off. Okay? In order to do it, then supposed to be no diode here. What we have?
0.7 volts?
I said no diode there. If you don't have a diode here, no diode here. What we have? If you don't get a diode here, what we have?
5 volts.
Correct?
Correct.
Vout will be equal 5 volt. No diode. Okay? So, now you come up with the diode on or off. You get a 5 volt. And this side, the other side, you get a round. Okay? Diode on or off?
Is the diode off this time?
Perfect. Diode off. The thing is anode less than cathode, so the diode off. Now, again. First thing you have to come up diode on or off. Now, if a diode off, you substitute diode by open. Okay? By open circuit. So, diode on or off, answer will be off. What we out?
V out will be 0.
V out will be measured from here to
Oh,
round.
5 volts.
5 volts. Perfect. What is the current I? The thing is now they will be open, correct? No current flow, right? The thing is they open.
Five milliamps?
No, they open. How come the current flow? Current flow this way. And now they open here. Current cannot flow. Make sure you understand. When you say the diode on or off, then you substitute diode. In this case, you say they open. They off, that means they open. Forget this one. We don't care about that anymore. When they open, that means no current can be flowing. So that's why current equals 0. And V across R, that means the voltage across here. VR equal what? What VR equal?
Is it 5 volts?
VR means the voltage across R. Okay, I'm telling you, VR I have R. What I equal? 0, right?
0. 0, yes.
Time R.
So it means with the circuit open, there's no voltage, neither current as well. Well, the voltage is there, but the resistor 0.
Okay. VR equal I time R. I equal 0. Open, no current flow. That's why VR equal 0. Okay? Any question regarding to example 1 or 2? Okay, if it's not, we go. Okay, number 3. 14. Again, if you're looking into a circuitry with the diode, you have to come up with diode on or off. That's the first thing you have to do. So, for the circuitry, okay, this diode right here. Can you tell me diode on or off?
It's on.
I think it's off.
Off. Why? I know. If I'm looking here, okay, I can see this can be 5 volt, right? And the other one will be 8 volt. 5 volt will be less than 8 volt. So diode will be off. Now, after you say diode off, we're not using diode anymore. Substitute diode by the circuitry here. Okay. Off, they will be open. Right? And this is a battery 8 volt. Okay? Forget this circuitry. You're working with the circuitry. Diode off. Okay? So diode on or off, you say off. Go to 9. That means if they're working, they will be get current flow this way. However, diode off the open, I will be equal 0. No current flow. Okay, any question on number 3? If you are good when you're looking into the circuitry, you can tell right away diode on or off. Okay, number 4. The question is diode is forward bias or reverse bias. Forward bias, that means on. Reverse bias, that means off.
Is it forward?
Okay, forward bias means on. Reverse bias means off. So, diode on or off?
Off.
Can you say again, on or off?
It is on.
Perfect. You can see this is a round. How many volts? 0. Round, right? On the other side, you get negative 100 volt. The voltage across the diode will be VD. This will be A. That will be C. VD means VA minus VC. And if you calculate here, VA 0 minus to minus 100, they will be equal 100 volt. That greater than 0.7 volt. So the diode will be forward bias. Okay? When you see the diode, you're able to recognize right away. They on or off, that's okay for me. Let's see, what else? Oh, now they go to another diode. Okay, you see that's simple. A little different from the diode. Okay, that's what they call, let's see, Zener diode. Zener diode. Okay, and anode here, cathode here. Okay, so this is the Zener diode. Normally, when you say Zener diode on, they will be substituted by the battery. However, this battery equals V Zener. For example, you go into electronic store, you want to say, okay, I want to buy a Zener diode. And they will be asking you what the Zener voltage. You have to tell the voltage. Like you say, okay, 5 volt, Zener diode, 10 volt, Zener diode. That's okay. Okay? So this will be equal VZ. Okay? They can be any voltage, but they must be at that voltage. That means break down diode. I given you example. If you can buy VG 5 volt, okay? So in case this voltage here equal 20 volt, that means the signal will be breakdown. You cannot get 20 volt here. You will be get only 5 volt. You know this signal diodes here, they're using everywhere. Like inside the computer. The computer using only 5 volt. No more. So the voltage when they come into the computer, they get the zener diode 5 volt. In the case the voltage coming in more than 5 volt, they break it down. They get only 5 volt. Okay? That prevents the damage inside. Okay? Computer. They using the zener everywhere. Need the power supply. For example, I need the power coming to the circuitry only 10 volt, no more. Then they need the zener diode 10 volt. So any power applied more than 10 volt to the circuitry, they break it down to be 10 volt only. That is the purpose of the zener diode. Now zener diode working normal. Now working normal. Then they working like normal diode. See that? If the diode on, substitute by battery 0.7 volt, nothing else. Okay? So for the zener, either they can be breakdown voltage or they can be normal zener working, diode working. Now see what they said in here. Major application in a diode type of voltage regulator for providing stable reference voltage for use in power supply or voltmeter or other instruments. Okay? Like you know, you get a voltmeter. Inside it using 12 volt. Then they have to get a zener voltage 12 volt. Any higher 12 volt, they cut it down to 5 volt only. Otherwise, they will be damaged to that meter. Now, the next. Okay, now we're working with this circuitry. Okay, for this circuitry, okay, zener here, the voltage will be 10 volt. VG 10 volt. Okay, now to the diode, either zener or normally. You have to, for the V-zener, okay, or normal diode, first thing, you're supposed to be No Zener diode there. Okay, forget this guy. What we out? I given you the note here. First thing you say, if no. Okay, Zener. What happened?
10 volts?
What we out equal?
10 volts?
See, how come you get 10 volts? I say no V out, no Zener. That means I take the Zener out. Then what V out? Then V out equal what voltage? Forget about the Zener here. What we out? Okay, now I'm telling you again. Okay, you get power here. V out plus here 20 volts. What V out equal?
Is it 91 milliamps?
Come on. My question is, you get the 20 volt here. R register here and open here, V out. What V out equal?
$19.8 volts.
How come you come up with something? Okay, you understand A. V I time R, right?
Yes.
What I equal?
0.0.
0 M. Open, how come the current flow? Can you see that? When you get the open, how come the current can be flowing? Now, I can tell you, if you get a copper, okay, this is the copper. Okay, you heat up here. Can you hold here? The answer have to be no. You get hot. The thing is copper to get an electron. Okay? When you heat it up, electron moving. That's why you cannot hold it to get hot. However, okay, this just a wood. then you can hit one side, you can still hold another side. They're not conducted, no current flow. Okay? So that's why I'm telling you, if you try to fix anything, okay, in electric at your house, make sure you have to stand over table. The thing is the table is good, cannot conduct the current. Okay? So you get short current can flow through your body. When they hit into the table, open. So that's why you're okay. Okay? So okay, now going back to the problem here. You get 20 volt and you get Zener 10 volt. Okay, again, with a diode, you can see normal diode, then you have to come up with diode on or off. For the Zener diode, same thing. You have to know Zener diode on for Zener or on for normal or off. Okay? In order to do, first thing, we have to suppose to be no Zener here. What we out?
Zero.
How come you get zero?
There's no ground.
I already tell you. V equal I times R. Ohm law.
You got an open circuit, so Zener is 20. I mean, the voltage on the end there is 20.
Correct. You get the 20 volt here. And the current flow here will be zero. The thing is no diode here. They open. Current zero. So the voltage here and voltage here must be the same. So they supposed to be ready. Without Zener. Is it correct?
Correct.
Okay, now, when you get the Zener, okay, when you get the Zener, that you get 20. 20 volt higher than 10 volt Zener. Okay? So Zener breakdown.
The Zener breakdown is 20. I mean 10.
Zener breakdown. My question is, how? How come Zener break down?
Because the manufacturer made the Zener. Is that 10 volts you got there?
Yes, now you already come up with you say Zener breakdown.
Okay, but is your Zener breakdown 10 volts?
Yes, the Zener is 10 volt.
Okay, then the answer is 10 because
Exactly.
20 is higher than 10, and
Exactly.
Zener's it
But
goes
it
according to the
cannot be
manufacturer.
10. Cannot be 20. Now they will be
10.
10 volt. Okay. Now, number 1. A. What is V out if V in equal 20 volt? The answer will be Zener breakdown. Then V out 10 volt. Okay. Now, if you get any question, okay, tell me.
The Zener breakdown, Mr. Pham, that's the same as like it acts like a regulator, right?
Yes, that means they try to protect V out cannot be higher than 10 volts.
So we can call it a regulator, right?
Mm-hmm.
Okay, thank you.
Make sure if you get any question, just let me know. Try to understand. This is a very, very basic. Okay, number 2. They asking about golden eye. Okay, you understand the Ohm law. I equal V. Okay. V. That means the voltage difference between 20 volt and 10 volt. 20 minus 10 divide 220. Okay. That means 10 divide 220. Okay, 10 divide
Oh,
200
is it 0.05?
0.0455 ampere. Ampere. Okay? Up to this point, any question? Okay, if it no, so the current go through 0.05 amp. Now, next question. If VE equal 5 volt, okay, so now they change that to 5 volt. Okay,
I think it says -5.
okay. If they change to 5 volt, what we out? That means now we come up with to see with the input 5 volt, what diode? What happened to the diode? They will be breakdown, or they will be working normal, or whatever happened. And we have to come up with that. Okay? Now if you get a 5 volt, telling me what happened to the Zener diode? They break it down, or they can be normal. First thing, if you don't have a Zener here, no diode here, what we are in here?
5 volts?
Perfect. Now you get much better. Then you say you're supposed to get 5 volt. Okay? The 5 volt compared with the Zener 10 volt. So the diode not break down. Okay? First thing I know, diode not break down. Okay. Diode not break down. You can see here, they go back to normal diode. Just go back to normal. Okay? So I can draw the diode now. You can see this diode here. Okay? Negative here. Positive here. Plus minus 0.7 volt. Okay? On this side, you get 5 volt. On this side, you get ground. So what happened to the diode?
Oh, you mean like
They asking for V out.
yeah, but you're talking about like reverse bias or something?
What?
Are you asking about the bias?
The diode?
No, are you asking about the bias?
What to say? I could follow. My question is, they change the input to 5 volt. If no zener, then you get 5 volt. Correct?
Correct.
Forget that guy. And zener, they not break it down. You have to substitute zener diode by regular diode. Positive, negative, 0.7 volt. Correct?
Correct. Correct.
Okay. So the question is, if we in 5 volt, what is we out?
4.3.
How come you get 4.3? Now you come up with this diode for this time. You get 5 volt here. You get ground here. What happened to the diode?
Is reverse bias?
I want to know they on or they off.
The diode's off
Diode off. That means,
because 5 volts is greater than the
ground,
0.7.
right? 5 volt on this side. Ground on this side.
Ground is equal to 0.
0. So the diode off
Off.
or reverse bias. When they off, they will be out.
Open.
Open. Open here. What voltage be out?
The voltage V out is going to be 5 volts.
5 volt.
Hey, Mr. Pham or somebody in the audience, isn't 20 minus 10 equal to 10, and then you divide the 10 by 220, so you get 4 something.
0.045 or whatever.
Yeah, you get 0.045454545.
You take 10 divide 220. What you get?
You get 0.045, which is basically 45 milli.
That will be ampere. Right?
Right.
0.05. 0.0045 is okay. No big deal. Okay? Now, I see who can do that one. Okay, you get 24. Okay, you get the zener 12 volt. You get the load 490 ohm. Okay. For the circuit sold,
Is that 470 ohms?
what do you mean 70? 470 ohm.
470.
Right. Now, first thing, for the circuit sold, shown for no load. That means right now we try to solve the problem without the load. Okay? They want to know what the IL. This is the IL here. Okay, so again, when we deal with the diode, you have to come up with diode on or diode off. Okay. If the diode is a zener, then the diode will be working like zener diode. Okay. Or they working normal diode or no, nothing. So again, I try to repeat it. First thing, without zener, what is VL?
Is it 24 volts?
Perfect. Now you good. Without VL, okay? Without, what is VL? Okay, without load, okay? VL equals 24 volt. That means 24 volt here, correct? Now,
Yes.
then you come up with the zener. Zener breakdown or not?
There is a breakdown down to 12 volts?
Perfect. Zener is breakdown, correct? Then
Yes.
zener breakdown. Okay, that will be telling you. Then V out 12 volt. Okay? So now V out equals 12 volt. Okay, so they want to calculate the IL. Okay, basically, okay, the current IL, you get the current IG, I total. That will be get the current I total. Current going down here. Current IG. Current IL here. Okay, so basically IL, the thing is no analog, so IL will be 0, correct?
Correct.
And now they want IG. Okay, IG. If you want to calculate the IG, equal -24 minus 12 divide 470 ohm. Okay,
0.025.
okay. 12 minus, no, 12 divide 470.
Is that 0.0255?
0.025 ampere. And they want V out. V out with the load. Okay. Now they connect the load in. Okay. So this is the 12 volt. When you get the load, that means V out, same thing, will be 12 volt. IL. With the load, they asking for current IL. That will be simple. You get the 12 volt. Divide 490. Okay, 12 divide 490. 0.024. Ampere. And now they want to get the IG. Okay. So the total current. Okay. And basically IG with the load. That means now you get the 12 volt here. You divide 490. That's what you get, 0.024 amp. And they want to know this current. So you need to calculate the I total. I total equals 24 minus 12 divide 470. We already did it. Okay. Let's see. ID, where we get it. We
Right above IT.
right here, right?
Yeah, yeah, you got IZ is equal to 24 minus 12 over 470, and it gives you 0.025.
24
And you're doing the same thing again.
minus 12 divide 470. That's what equal 12 divide 470. We already did it. 12 divide 470. 0.025. Okay, 0.025. When they go into the, let's see, you get IL 0.025. Okay, and that the total here. Let's see. Twelve divide 470. Is it 0.025? And the current flow 490 here. What the current? ID 0.024. Okay, so ID equal I total minus I low. IL equal 0.25 minus 0.024 equal 0.001. That will be IG. Okay, so I will be stop at here. Okay, again, for next week, you will take one. Will be in room 240 for lecture at 3 o'clock. I don't want to working on Friday. Okay, we want to get free on Friday. Okay, no class, no thing. We working Monday, Tuesday, Wednesday, Thursday. That's good enough. Okay, so next week we'll be continuing with the dial. Try to go through it. Okay, to make sure you can understand. Okay, I try to give you a real simple, and I try to see how many people can get through it. So, do you get any question, anything before we can stop it?
Did you record this?
Yeah, I did. Okay? No question, nothing. This time I saw more people in the Zoom. That's perfect. However, this is we try to training for you to be a real technician. Okay? Whatever do not understand it or follow it, just let me know. We will be helping you. This is we build a very, very basic. Okay? Try to go through the handout again. Try to see on the Zoom. I will be upload the Zoom tonight. Okay? Make sure you understand. Okay. If you don't have any question, we'll be stop it. Okay? Have a good weekend. To all of you. Okay? We'll see you on Monday. Bye bye.
Thank you.
Thank you.
You're welcome. Bye bye.
Thank you.